In this video, I want to look at the solution to question 6 from Trigonometry 2, exercise level 2. So in this question, we have a circle with two chords, a longer chord of length 11 centimetres, and then a shorter chord of length 8 centimetres. And what we're asked to find is the area enclosed by these two curves, so this area here, and also the perimeter of this section, so the length that I am covering in red. And to do this, I'm going to draw this circle out again twice, once with the longer chord and once with the shorter chord. So when we have the longer chord of 11 centimetres, we're also told we have a radius of 6 centimetres. And we don't know the angle subtended at the centre here by this chord, but let me call this theta. And also we have the same circle and a shorter chord of length 8 centimetres, and again we have a radius of 6 centimetres, and we don't know the angle at the centre yet, but I'm going to call that phi. So in order to find the perimeter, it'd be useful if we could find both of these arc lengths. And if we then subtracted those two arc lengths, that will give us the curved part of the section we want. And then to find the total perimeter, we just then need to add on 11 and 8. And to find an arc length, we know we have a formula for that. So if we know we can find the angle at the centre, we can calculate. Because we have the radius, we can find that arc length. Okay, so what I'm going to do is I'm going to draw on a radius that bisects the chord, and we know the radius that bisects the chord meets at a right angle. So we have a right angled triangle here. We can do the same thing on this second circle. So if we draw out this triangle formed, we have a right angled triangle, we have a hypotenuse of length 6, and this angle here, because this is bisected and they share the side and the hypotenuse, we know that those two are congruent triangles, so we know that this angle here is theta over 2. And we also know that this length here is 5.5. And similarly for the second chord, we have a right angled triangle, and we have a length here of 4, a length here of 6, and this angle here is phi over 2. So just using some trigonometry, we know that theta over 2 is sine inverse of 5.5 over 6. And similarly for this case, we have phi over 2 is sine inverse of 4 over 6. Okay, so that means that theta is equal to 2 sine inverse of 5.5 over 6, and phi is equal to 2 sine inverse of 2/3. And we want to find the arc length. So we know that the arc length is equal to r theta. So in this case, we have r theta equals 6 times 2 sine inverse of 5.5 over 6, which is 12 sine inverse of 5.5 over 6. And in this case, it's not r theta, it's r phi. R phi is equal to 6 times 2 sine inverse of 2/3, which is 12 sine inverse of 2/3. Well, now we know to find the total perimeter, we need to subtract the smaller one from the larger one. So the perimeter is going to be equal to 12 sine inverse of 5.5 over 6, subtract 12 sine inverse of 2/3, and then we just need to add on the 11 centimetres and the 8 centimetres, so plus 11 plus 8. And if we calculate this on our calculator, ensuring that we are in radians mode, then we should calculate a perimeter of 21.16 centimetres to 2 decimal places. We're also asked to find the area here. So to do the area, I'm going to do the same thing. I'm going to draw out both of these circles with the... I'm going to draw out this circle again with the two chords, and we're going to think about how we might find the area. So if we do the larger chord of size 11, we have a radius of 6, and I have the smaller chord of size 8 and a radius of 6. If we can find this area here and then subtract this area here, we'll be left with the area bounded by those two curves. Firstly, I'm going to label these angles the same as we did before. So this angle here is theta, and this angle here is phi. And we know how to find an area of a sector. We know the area of the sector is a half r squared theta. But then we want to subtract the area of the triangle. Well, the area of the triangle we know is a half AB sine C, but in the case where we have the triangle with the two radiuses and an angle theta, this just becomes a half r squared sine theta. So if we want to subtract the area of the triangle, we are subtracting a half r squared sine theta. And factorising that, we get a half r squared theta minus sine theta. Similarly, in the other case, the area of the shaded area here is going to be a half r squared phi subtract sine phi. So the total shaded area is just going to be the difference between these two. So a half r squared theta minus sine theta subtract a half r squared phi minus sine phi, or taking a factor, a half r squared theta minus sine theta minus phi plus sine phi. And we know what r is. R is 6. So what we actually have is we have a half of 6 squared, which is 18, lots of theta minus sine theta minus phi plus sine phi. But we've also calculated phi and theta. So we know that theta and phi, as given above, are here and here. So making those substitutions into this equation, we can calculate the total shaded area. So if we make those substitutions of theta equals 2 sine inverse of 5.5 over 6 and phi equals 2 sine inverse of 2/3, we end up calculating the total area is 20.18 centimetres squared to 2 decimal places.